Before this goes any further, I want to correct the record on something, because what actually happened here is more remarkable than the exaggerated version making the rounds online. There is no unsettling, terrifying new image that James Webb captured 5 minutes before this video started. What's real is something quieter and honestly more impressive. An interstellar visitor passed through our solar system last year, and instead of relying on one telescope to study it, NASA turned an entire fleet, nearly a dozen separate spacecraft and observatories, toward the exact same object, all at once, to build the most complete visual and chemical record of a body from another star system that humanity has ever assembled. This is the real story of what those instruments actually saw, and what NASA's own scientists said about it when they finally sat down and reviewed everything together. The object is called 3I/Atlas, and it was first spotted on July 1st, 2025, by the NASA-funded Atlas survey telescope in Rio Hurtado, Chile, an instrument specifically built to scan the sky for exactly this kind of moving target. Within days, follow-up observations confirmed something extraordinary. This object's orbit was hyperbolic, meaning it hadn't formed anywhere near our sun and wasn't looping back around it the way every native comet and asteroid does. It had arrived from interstellar space on a one-way trajectory that would carry it back out again once it passed through, and it became only the third confirmed interstellar object in the entire history of astronomy, following Oumuamua in 2017 and Borisov in 2019. What happened next is what makes this story genuinely worth telling properly, because interstellar objects are so exceptionally rare, and because 3I/Atlas was passing through at a moment when an unusually large number of NASA's active missions happened to be positioned well enough to actually catch a glimpse of it, the agency assembled what amounted to a coordinated observation campaign across almost every instrument capable of contributing. Hubble captured its first detailed image on July 21st, 2025, when the comet was still 277 million miles from Earth, revealing a glowing, teardrop-shaped cocoon of dust streaming off a solid, icy core. NASA's James Webb Space Telescope followed on August 6th, using its near-infrared spectrograph to begin building a chemical fingerprint of the object, later revisited in December with its mid-infrared instrument for an even deeper look. The SphereX Observatory, a mission built to map the entire sky in infrared light, spent roughly a week in early to mid-August 2025, collecting its own data, then returned again in December for a follow-up round that captured a sharp brightening in the comet as it approached the sun. Ground-based instruments joined in too. The Gemini South Telescope in Chile photographed the comet in late August 2025, documenting its tail, visibly stretching longer as solar heating increased its activity. But the campaign didn't stop with dedicated astronomy telescopes. NASA's exoplanet-hunting TESS spacecraft, normally busy watching distant stars for the telltale dimming caused by orbiting planets, was redirected to capture footage of 3I/Atlas in January of 2026. The Psyche spacecraft, currently en route to study a metal-rich asteroid, managed 4 separate observations of the comet across an 8-hour window as it happened to be in a useful position. The Lucy spacecraft, on its own long journey to study the Trojan asteroids near Jupiter, spotted 3I/Atlas from about 240 million miles away. Even NASA's Stereo mission, built to monitor solar activity, and the newer Punch mission, designed to study the sun's outer atmosphere, and MAVEN, a spacecraft orbiting Mars to study its atmosphere, all contributed observations, each one adding a different piece to the overall picture, imaging the comet's tail, its surrounding hydrogen envelope, or its position against the background stars from angles no single mission could have captured alone. NASA's own Perseverance rover, sitting on the surface of Mars, even contributed to the effort. Altogether, nearly a dozen separate NASA assets, most of them built for entirely different purposes, ended up contributing observations to this single object during its brief pass through our solar system. So, what did all of that combined effort actually reveal? On the chemistry side, both Webb and SphereX confirmed something genuinely unusual. 3I/Atlas was releasing an extraordinarily high ratio of carbon dioxide compared to water vapor as it warmed near the sun, with early Webb measurements from August 2025 finding that roughly 87% of its total gas loss by mass was carbon dioxide, compared to only about 4% water, with most of the remaining material being carbon monoxide. For comparison, comets that formed within our own solar system typically show far more balanced ratios between these compounds, since they generally formed at similar distances from a similar star under broadly similar conditions. This comet's chemistry pointed toward formations somewhere with dramatically different temperatures, and likely a very different chemical environment entirely, than anything that shaped the comets native to our own solar neighborhood. On November 19th, 2025, NASA held a public briefing specifically to review everything gathered so far, and the tone from the agency's own scientists was refreshingly grounded. Tom Statler, NASA's lead scientist for solar system small bodies, told reporters plainly that the object does the same things ordinary comets do, evaporating both carbon dioxide and water as it's heated by the sun, just with an unusually high proportion of carbon dioxide relative to water, which he described as genuinely interesting scientifically, without ever suggesting it pointed toward anything exotic or artificial. Nikki Fox, the head of NASA's Science Mission Directorate, added that the object was always going to look different from anything we're used to, precisely because it didn't come from our solar system in the first place. And that difference, she said, was exactly what made it worth studying so closely. There was one more genuinely surprising observation buried in the data that's worth understanding properly, because it shows just how carefully this object was actually tracked. On January 22, 2026, the Sun, Earth, and 3i/Atlas happened to align almost perfectly along the same line, an alignment astronomers refer to as opposition. At that exact moment, researchers measured a real, statistically significant spike in the amount of sunlight being scattered back toward Earth by the dust surrounding the comet, a roughly 20% surge in brightness concentrated within a narrow few-degree window around that precise alignment. This kind of brightness surge, known as an opposition effect, is a well-understood, physically explainable phenomenon caused by countless tiny dust particles in the comet's surrounding coma, essentially hiding their own shadows from an observer's point of view only when the sun, the observed object, and the observer are lined up almost exactly. It's been documented before on other solar system bodies covered in fine, loose particles, and its appearance here gave researchers extra insight into the size and structure of the dust grains making up the comet's glowing halo. It's a genuinely interesting, carefully measured result, and it happened because the timing of Earth's own orbit briefly lined up with this object's outbound path, not because of anything mysterious about the comet itself. Taken together, what nearly a dozen NASA missions, working in loose coordination across 9 months of observations, actually documented was a real, physical, icy body, behaving according to well-understood cometary physics the entire time, releasing gas and dust in response to solar heating exactly the way models predict, just built from a chemical recipe that looks meaningfully different from anything that formed inside our own solar system. That's not a small finding. It's a genuinely rare, carefully earned scientific result built from an unprecedented cross-agency observation campaign that most single discoveries never come close to receiving. But it also isn't a shocking or unsettling one. It's the kind of quiet, methodical confirmation that real planetary science actually looks like when it's done properly, methodically, and out in the open. Exactly the way NASA's own briefing described it in plain, careful language back in November. 3i/Atlas made its closest approach to the Sun on October 29, 2025, and has been speeding back out toward interstellar space ever since, fading from view as it goes, carrying with it the last opportunity anyone will ever have to study this exact object up close. What NASA and its fleet of spacecraft managed to capture during its brief pass through our neighborhood wasn't a single dramatic photograph. It was an entire coordinated body of evidence, gathered from telescopes on Earth, in Earth orbit, near Mars, and out among the asteroids, all pointed at the same tiny, ancient traveler at the same time, confirming carefully and repeatedly exactly what it is, and exactly how strange and how genuinely valuable its chemistry turned out to be. If stories like this, the ones where the real, carefully documented science turns out to matter more than the exaggerated headline built around it, are what you come here for, stay close, because there is more still arriving from the data, one confirmed observation at a time.